Hello learner, how do you do? Welcome to Manifested Online Classes. My name is James Kenyani. In this lesson, we are going to introduce a new topic, Surds. So before attending the lesson, the learner should be familiar with the expressions written in root form, which were discussed in Book 2. So revision of square roots and cube roots is necessary. In this topic lesson, the learner will be introduced to rational and irrational numbers. The objectives of this topic are: 1, the learner should define rational and irrational numbers. 2, the learner should simplify expressions with surds. And lastly, the learner should rationalize the denominator. But as they say, you cannot chew a lot once. That's why in the first lesson, we are only going to look at rational and irrational numbers. The main objective, so the lesson is rational and irrational numbers. Rational and irrational numbers. Rational and irrational numbers. So in this lesson, the main objective is for the learner to differentiate between rational and irrational numbers. Rational and irrational numbers. So that is the objective. So we begin with rational numbers. Let's begin with rational number. So a rational number is a number So learner, as you look on the board, a rational number is a number which can be written in the form of P divided by Q, where Q is not 0, and there is no common divisor of the numerator and denominator, except one. So numbers like 2, we have 2, a half, 3/4, square root of 4, cube root of 8 are rational numbers, are examples. And it is true from what we saw that there's no common divisor of the numerator and if we have a denominator except 1, 3/4, 1/2. We are also told terminating decimals and recurring decimals are also rational numbers. So terminating decimals like 0.2, 0.125, 0.375 are rational numbers. And one would ask why? Why the case? because if you write 0.2 as a fraction, it is 2 over 10 learner. 2 there goes there 1, 2 goes there 5. If you write 0.25, 125 as a fraction, it is 125 over 1,000. 125 goes there 1, 125 goes there 8. If you write 0.375 as a fraction, learner is 375 over 1,000. 125 goes there 3, and there it goes 8. You see, you get rational numbers. You get a rational number. It can be written in the form of P divided by Q. We are also told recurring decimals like 0.3. When I put a dot there, you can write those 3's to the end of the world. To the end of the world, comma, 0.166 is recurring, are rational they are rational numbers. They are actually rational numbers because 0.3 converting to a fraction is 1.1 over 3, a rational number. 0.16, 6 recurring, works to 1 over 6, works to 1 over 6. So that's why the recurring decimals also get into that category. Now we shall look at irrational numbers. Irrational numbers. So you find when we shall be dealing with the topic, most of the numbers will be written in root form, either square root or cube root. And you find most of the rational numbers, they had a perfect square or a perfect cube root. Let's look at square root of 4. What is square root of 4? It is 2. What is the cube root of 8, learner? The cube root of 8 is 2. So you'll find most of the rational numbers, they'll have the perfect squares or perfect cube roots. When we come to irrational numbers, most of them will not have a perfect square or a perfect cube root. So examples of rational numbers are, and I'm going to give examples from 0 to 10, where we have the surd or the root form, are square root of 2, square root of 3, square root of 5, square root of 6, and square root of 8, square root of 9. There is something you discover. Like 1, the square root of 1 is 1. The square root of 4 is 2. The square root of, so this is not there. It is supposed to be square root of 7 and then square root of 10 learner. So you realize square root of 1 is 1, square root of 4 is 2, Square root of 9 is 3. So between 1 and 10, these ones don't have the perfect square root. You realize all of these irrational numbers do not have a perfect square root. Do not have a perfect square root. They do not have a perfect square root. You are also told pi is also an irrational number. Is also an irrational number. When you express it, it is 3.142. It doesn't occur in the recurring decimals. It doesn't occur in the recurring decimals. So just a recap of what we've done, what a rational number would be. A rational number can be expressed in terms of P and Q, where Q is not 0, and there is no common divisor of the numerator and the denominator except 1. And I've given examples where we had the root form like cube root, it was perfect. But now we also included the terminating decimals and recurring decimals. So the only difference when we come to irrational numbers, most of them that would occur in the root form, like square root, they do not have the exact or the perfect square root. They do not have the perfect square root. So in the assignment, so learner, in the assignment, you'll classify the following as irrational or rational number. Irrational or rational number. We have square root of 11, square root of 8, square root of 16, square root of 25, fourth root of 32, fourth root of 16, and square root of 21. Note that, learner, where you'll get a perfect one, a whole number, that will be a rational number. Where you cannot get a whole number, that will be an irrational number. So thank you very much for the audience, and let's meet in the next lesson as we continue learning about surds. So thank you very much. Have a nice time. Let's meet in the next lesson. Bye-bye.